the server farms running the Nvidia Blackwell chips are running them at around 70 to 80% cycle rate. Okay, and they are burning out at 33% a year. They're being and because they're buying them, and it's an expensive purchase, right? Anytime you buy these things, so the company's buying them or amortizing them over 7 years, like you would any large purchase as a business. But at year 3, they're already at like 120 something percent of the year 1 purchases, and they're not accelerating those write-downs. Okay, and so
welcome to Fire Talks by Tech Wing Bites. I'm Clint. I've built software, led teams, and now a founder, helping builders who are ready to make the leap, but can't quite see the path yet. Every episode is one conversation closer to clarity on ownership, execution, and momentum.
Today is going to revolve around AI chips, but of course, if you have something you want to share, that's fine. I sent you the email. I assume you had a chance to glance at it.
Yeah, it's a couple. Yeah, it's a couple. Yeah, it's a couple of them.
Yeah. And I'm gonna go ahead and put him on the spot. David is our pro. But let's at least do some introductions. All of you guys know who I am. Hassan is my business partner. He helped me out with Tech Wing Management as we continue to build. But Hassan, do you want to go ahead and introduce yourself?
I'm Hassan Fazet, Clint's business partner, helped him build Tech Wing Management. But no, I'm more of a operations / nonprofit grants type guy, and I know enough about and on the technology side to be dangerous, but definitely looking forward to hearing what you guys have to say, and then being able to get you guys to explain it in layman's terms, so that I can be able to kind of grasp it. So I always enjoy these talks.
Wonderful. Kevin?
Hello, everybody. My name is Kevin. Right now, I'm in the process of, I've been researching and developing a business for a while, actually, which is funny. But 2026 is the year that I'm going to put a lot of things in motion. Basically, what it is it's like a method of generating funds that utilizes crypto, art, and various other media mechanisms to generate passive income for people. So it's just a matter of putting it together and making it happen. But it's good to join you guys and listen to your thoughts.
David?
Yeah,
thank you,
sure.
Kevin.
So my name's David Seaholm. Been around technology since I was a young kid. Grew up with my uncle was an IBM engineer. My father did UX before UX was a termed thing for the government. And went to school for computer science and electrical engineering. Built a business when I was in school so that I could eat, and fell in love with business process as part of that. Became a technology executive basically my entire career. I'm also in the middle of starting my own businesses at the moment, which is it's been an interesting year. So yeah, that's my background. A lot of hardware, a lot of software stuff background. So
thank you, David. Tony?
Oh, it's on me now, right? Okay.
Yeah.
Oh, yeah. So yeah, Tony Brooms. I've been in technology for quite a bit. Actually, kind of similar to you, Dave, but in this case, it was my brother, my older brother. He was a IBM salesperson, so he actually brought home my first computer, which is the IBM PC Junior. But I've been doing technology, computer science for a while now. Started my own business called Ola Billy. So what we aim to do is really bring invoicing to a simpler way of doing things, right? So we actually employ text messaging in order to facilitate that transaction between client and customer. And so, yeah, that's what we've been doing, and using a bit of AI to kind of to push it along. So we've been learning as we go, and yeah, that's been where I am so far.
Thank you. Thank you. Yeah. I met with Tony a couple episodes back, and he showed me ngrok, and I've been all over it. Ngrok. Well, I might say it wrong. Why don't you tell him what ngrok is? Because I might say it wrong.
I mean, it's basically a tunnel. It's a way for you to, well, at least what I use it for is I kind of spin up my things locally, but at this point I'm also able to host it on the web, so I can have access directly to my system when I try to test things out locally. So, part of what we're doing, part of what I do is, there's a front end system and a back end system. So this allows me to test out the whole process without having to push everything up to a production environment.
Pretty cool stuff.
Yeah, it's a tunnel which helps you do that basically.
Yeah. Thank you for sharing that.
Yeah.
So I dove through those videos, and I did know a little bit about the regular GPTs, right? And chips, the AI chips, and going through those videos, seeing, and of course through conversations with David about the Google whatever the acronym is. What's the acronym?
You.
Yeah, TPU. That's it, right? But what I didn't know is there's so many people making chips. I actually know a friend who actually work on the chip level. He's not doing like software programming, but chip programming, specifically AI chip programming. So I didn't realize how much of a big deal it is. And to see Apple entering into the race now by I guess they're thinking about it from the sense of adding AI chips to their devices, so that you can pretty much run LLMs locally. I think the goal it seems like the goal is, since the security around AI is seemingly a challenge, maybe people just trying to have like an internal network, and that begins with the chip. But that's one of the points that came out for me. What was y'all thoughts?
I think that the security aspect is a selling point for the manufacturers. That's not reality. It's not what they're trying to. They're trying to offload work onto the devices and consume your power and not theirs. Right, and it's more responsive and other things, but yeah, especially on the query side. So when you formulate, your prompt to whichever LLM that you're going to send it out to, they then have to go and build the whole vector space for that prompt and process that. So anything that they can do about organizing that or getting it that vector ready before it gets to their systems, it helps them out massively. So
what does ready in context mean?
Well, I mean, just turning it into a vector for one.
Just turn it into the vector.
Yeah.
Okay. Interesting.
Yeah.
But when it comes to chips, though, like one of the biggest kryptonite per se is just energy, right? More and more power, more and more power. That's how I understood it. Are you seeing it the same?
I mean, you're talking about for the on-device chips that. I mean, by the way, those
sorry, go ahead.
Those are already there. They're already in the devices. But
but when you look at it from a large scale, from these organizations, Microsoft and so on, housing these chips, then it comes down to more and more power, more and more infrastructure. So when you put it on the phone with our lithium batteries and our laptops in the future, I mean, yes, some of it is there, but I'm saying progressively, do you think those devices then would pull more energy?
Exactly, which means that the battery life isn't going to last as long.
Right. That's exactly what I was getting.
Yeah. So again, it goes back to it's a selling point, right? It's like, but it's more secure for you because your information is not going directly to whoever it is that you're sending it to. Well, you're going to send it there anyway.
You're still getting it.
Yeah.
It feels almost like it's almost like not modern, because this has always been modern, but it's like a client server architecture, right? So they offload a lot of that information onto your device, which is essentially the client, and then sends it up to the server to eventually, not generate the vector, but to utilize the vector that was generated on the client side to then go into the space, and you search and figure out what the query and the answers to that question that was built out on the client. So they've offloaded some of that to you in order to make it a bit more efficient for themselves.
Yeah. So for instance, like, have you started using projects inside of Anthropic yet, inside of Claude?
I've used Claude.
So you have like all of your files and everything sitting there, so you have it your own kind of surface that you've provided it. If you can offload that surface onto the device instead of up in their server, that's a huge cost savings for them, right? And that's part of building out that vector space. It's not just like, okay, I'm going to take your prompt, I'm going to vectorize it, and then I'm going to send it. Like that's you could do that on a normal whatever architecture CPU. But if you're talking about going and organizing the context space or the surface that you're providing off of the device, that's where this type of stuff starts to play in.
So as the layperson in the back of the room, I'm hearing you guys talk about this, and of course, when and Clint, I think you and I talked about this a little bit when I was in Austin, right? About creating it using AI and having it learn you in a pretty much a safe environment, right? Because it's not open to everyone else. And it looks like what you guys are saying, they're the selling point as a salesperson, because I see this as a selling point, is saying, hey, this is so much more secure, and you guys will be able to utilize AI without feeling like you're sharing it with the whole world, when in essence you're going to. It's just you can start creating things in that secure space, and realizing, because only people like you guys are going to know that, hey, the reason why they're doing this is because they're trying to offload the power consumption on you as the user, right? And so because if you guys would have never said this, I'd have been like, this is the coolest thing ever, I can do my AI in this. And so when David jumped out and said, oh yeah, this is not going to work because blah blah blah, and I'd have like, yeah, it probably won't work for you because I never thought about that and would not have thought about it had you not brought that up.
I mean, but is secure sounds to me like the selling point, but the real benefit is speed, isn't it? Like efficiency.
I mean,
price.
I mean, right? Because if the server is doing some work and your device is doing some work, yeah, there's some secure tunneling going on, but they're not really covering any major security grounds there. It's like the same stuff we got today.
Yeah, I mean, other than your surfaces lives on your devices instead of up in the whatever cloud, but then you're also on the flip side, you have to have your surface on every single device you're using it from. Like right now with Claude projects, I can use it off my phone, I can use it off my computer, I can go grab a tablet or whatever, and I get to the same surface every single place. But I think it's trying to address the power issues that they already have, right? So they don't have and are not going to have the power to continue scaling this for the next decade.
Yeah.
We don't even have the equipment to build this stuff out. I mean, like if you are in the market to go buy a transformer, like you're going to wait 2 years to get it.
Yeah. So like you say that, and this is me being devil's advocate, right? Like a couple of years back, they were projecting the cost for all of these different devices that we need for the AI ecosystem, and it was expensive. And Nvidia is like, yo, this is how much it costs, blah blah blah. And then DeepSeek came out and say, yo, you can run this on this cheap hardware. So the question is, as we see it now, it is expensive and it's a lot, and we don't have. But would China come out with something tomorrow?
Well, they already have. An ex-Google engineer just put out.
Yeah,
I saw that.
Yeah.
Go ahead and explain it.
Yeah.
I mean that effectively it's a clone of the Google chips. I forget the name of them.
Yeah, I saw that in passing.
Or
I
like
didn't dig too
RT or
deep in it.
something.
What was it saying? What
Was
was
it
it saying?
Tensor RT or something like that? I remember hearing about it, but I can't remember.
Yeah, you're right. It's a tensor chip line. Yeah, effectively, it's a clone of those. But yeah, it's a low cost AMU chip that China's going to start developing. I think that so the problem with China is they're cut out from Taiwan Semiconductor and TSMC. So they can't get stuff built by TSMC directly. They have to go, through buying stuff through shell corporations, even get it into their country because it's illegal to export it there. Anything at 5 nanometers or below, that applies to TSMC. I think that China has the ability to do 7 nanometer. They have the right litho equipment. They can't get parts for it necessarily easily. Okay, so anything 7 nanometers and above, they can build themselves. And this chip on the tensor, but it's at 7 nanometers instead of the 5 below that Google and these other companies are building it at. So it's not as efficient, but it's cheap,
Right.
cheap to make, and yeah,
And hence probably cheap to connect in series and scale, possibly.
Oh well, yeah. I mean, but everything's really cheap when you have giant, weaker prison population to run all that for you. So
Yeah. So what do you see the downsides, right? Because here you have this Google developer creating this chip. Of course, it's low level, but it's still pretty powerful, right? And then you have the Googles and the Apples, and they just competing on this high scale. But to what end? You know what I mean? Like for what speed? Like they say to replace developers, but I think that's going to come to a crashing halt soon.
well, I mean,
yeah, probably more than replacing developers. I mean,
yeah,
it's the replacement of
factories,
a
probably
lot of workforce, right? It's
yeah.
what AI is in the long run is supposed to be doing the work of what people do. It's, but how far along the line do you get, and how far along we are with that? And we're pretty far away from something like that happening.
Yeah. Well, I didn't do as much digging, but I slightly saw that. And so Nvidia, so for you, Hassan, Nvidia has been making good graphics cards for a while, and the design of their chips just works for AI, right? And Nvidia's biggest competition with video cards, mostly for video games, is AMD.
Yeah.
And I'm not hearing much from AMD, and that feels weird to me.
So AMD does what are they called? The FPGAs. Yeah. So they're basically programmable gates that you can connect in line with a bunch of processors, and so you can create. Basically what you can do is you can create your own AMU or TPU or whatever it is thing that you want by configuring it. It's nowhere near as efficient as if you actually have one of those, but those are special chips for a very special purpose. I think for anybody that's not super technical on how chips are designed, you can think of so you have a city street, right? Or a city with streets in it, and you can choose what route you want to go to get to point B, right? Then if you take that concept and it's okay, that's like a graphics processor unit. Like you can choose however you want to get there. There's a million different ways. You could change it up every day if you wanted to. Then think about like the little kid's toy where you get the little ball to go through the maze, right? There's only one way to get to the very end, right? And that's what a TPU or AMU is. It has a path that you can take, and you can do it over and over and over again extremely quickly, but it's not multi-purposed. So and AMD is going to stick around with those programmable systems, specifically for being able to design your networks or your systems for the TPUs or AMUs or the 500 other architectures you have out there for doing specialized processes. but their market share is going to continue to shrink. Right now, you have entire clusters inside of servers that can be rented for AMD FPGAs.
Yeah. So that makes sense because I'm watching the video and some stuff is making sense and some stuff doesn't. So thank you for clarity because now I'm reflecting back on one of those videos I was explaining that. So it seems like then the newer chips is just providing more and more paths.
It's a specific path.
Less.
Yeah.
Less paths.
Yeah.
So faster to get from point A to point B.
Right. It's less complex.
Gotcha.
Right. Like you. So when you do your pipelining and everything, right? Have to. It's super simple. I mean, it just sits there. Did you ever study Cray vector machines?
I have not.
Okay.
Tony, you?
That's I might have did it a long time ago, but
you would have only seen it in school. I mean, those are super. I mean,
it's like assembly language.
3 of them, something.
All right. Huh. So it's like faster from point A to point B, and then the visuals that I'm reflecting on was like they're putting layers on top of layers on top of layers, which would makes it even more faster. I assume.
Yes.
With these chips, huh? Interesting.
Sort of. Yeah, that's a sufficient way to think about it.
So this might sound like a dumb question. So these are the GPUs, right? But the regular chips, how are they designed? I guess in quote unquote inefficiently to use AI. I'm talking about the other chips such as the Intels, the ones that goes into your computers, the non-GPUs, the CPUs. How are they different? Why were they not used instead of GPUs? I know GPUs is because of faster processing, because of the imagery, graphics and whatnot.
Yeah.
So this is why. But
I think part of it had to do with the fact that with GPUs, they were designed specifically to calculate these number crunch essentially. Because when you're talking about graphics, you're talking about a lot of matrix math, essentially.
Right.
To try and design to figure out where you are in in 3D space specifically. So that's a lot of calculations, and I think CPUs are much more generalized. Like they're designed to do a lot more different things, whereas GPUs were very specialized for that. And I mean, it almost feels like Nvidia the AI or Nvidia stumbled into it just because they were the ones they had the GPUs.
Feels that way, yeah.
It feels that way. I mean, I'm sure there was more to it than that, obviously. Yeah, because you don't just stumble into things like that. But
go ahead, sorry.
But it just feels. But as far as GPUs are concerned, they're a specialized chip that does the calculations quicker than a CPU normally does, and in parallel.
So how does this relate to in 2020 I wanted to buy a new video card and I couldn't get it because they were all being used for crypto. So how does these same cards that's being used for AI affect like the crypto market?
They weren't super efficient for that, but they were better than okay. So all right, so on a regular CPU that you have in your computer, right? It was advertised as having X number of cores, right? Okay. Each core, so you have your pipeline of instructions, right? And so anytime that the next clock cycle comes, it's going to execute an instruction. Okay. Right. So if your computer has 4 cores, it could conceivably do 4 instructions every clock cycle. A GPU, most of them have hundreds, some of them thousands of cores, right? And so they can do that many instructions in a single cycle, but their pipelines aren't as complex. They can't do as complex calculations. They literally do dot product and cross products of matrices. That's what they do. Okay, so yeah, I mean that answers your question. So if you need to crunch lots and lots of information to be able to get to an answer, and you can cross product or a dot product.
Wow, I'm learning some stuff. And Hassan, Kevin, I know that some of this stuff might be going over your head. So if you have any quick questions, this is the time. What's your questions? You want them to explain what vector is?
No, it's been a very interesting conversation. I have a general understanding of everything that's being said. I'm really curious, and I know it's way too early to have this conversation, but I always like to just throw stuff out just to get people's ideas and feedback. But I guess the question is, who's going to win, the chip race overall, which of course, like I said, it's impossible to predict, but it's a fun thought process, right? Nvidia has a huge lead over everybody else, but even with the recent purchase of Groq, they just took on Groq that was a former potential competitor. There's the overseas competition. Samsung is part of the Google pipeline. So I think that's what I would throw out there is like, how do you see the landscape just, even if it's just 2026, like I wouldn't say like who's going to win it all in the end. I think that's a little ridiculous. But do you think Nvidia keeps its stranglehold as far as being the dominant player, or do you think there's any upstarts coming up that we should pay attention to?
I'll say what my take on that is first, because I'd say the overall winner is not even going to be like Nvidia or Google. It's going to be TSMC because they're the ones building everything.
Yeah.
They're the ones that build. Everybody goes to them to build it. So they're going to be the ultimate winner. But
that's the one in Arizona, not the one in the Netherlands, right? Because I think Netherlands creates chips too.
They didn't.
That's Taiwan. They're Taiwan.
Yeah,
Taiwan. Okay.
Taiwan. I think they do have. They built out. They made one in Arizona, but I don't think that one is ready to make the sub fives yet. 5 nanometer yet.
No.
Okay.
But I'm sure they'll be coming really quickly.
Sorry.
What were you saying?
The one in Arizona just started making chips for Apple like a week and a half ago or something like that.
Oh, okay.
Oh. Okay. That's that's a different story.
Yeah, their efficiency is probably trash right now. They're just getting started.
So my question is, with this whole chip thing and how it's going to affect your average everyday startup or small business.
Mm-hmm.
What exists in that doesn't exist today that's going to give me some type of advantage in running my business or starting my business or being able to take my business to the next level?
Do you have an answer to that one, Tony?
Yeah, Tony.
My take on that is I wouldn't be too concerned with the chips so much as the service for that, just because what you're doing as a business, as a small business, I mean, what I'm doing as a small business is really finding the AI tools that is going to help me work faster and help me get my product out quicker, get it out the door. I honestly don't necessarily care if that is Nvidia, if they're running on Nvidia chips, if they're running on Google chips, because for you, for me, for anybody that's that level, we're concerned with the service. We're not concerned with that other speed, the speed of the chip per se.
Yeah,
right.
I largely agree with that. Like, I think that the winners in business in general with AI right now, or large language models as it really is, are people that are looking for building efficiency into their process, right? Force multiplication. The losers are people that are trying to replace people or processes. It's not there. There's too much nuance that we haven't figured out how to deal with, and the consistency of answers are not there either. The models need to be more mature and etc. I mean, there's just so many different things. I would say that I think that paying attention to the chip market though is important. Somebody just mentioned ngrok a minute ago, and and Nvidia's purchase of ngrok, and it being slated as a strategic purchase or whatever, right? But
Wait a minute, is it ngrok or Groq with a Q?
oh, sorry, it's Groq.
Yeah, I didn't realize that. I was like, predicted.
Yeah,
The
no,
Groq is
they're
that's the
completely
server.
different guys. Sorry, there's too many. There's like
Too many Groqs. There's Twitter Groq.
In any case, yeah. So the Groq, the one that Nvidia purchased, that was a bailout. They were about to fold.
Thanks for sharing it.
Yeah, they were one of the companies. So we kind of talked about this a little bit last time, but Nvidia has gotten itself into this cycle. So I guess I need to step back a little bit. The server farms running the Nvidia Blackwell chips are running them at around 70 to 80% cycle rate. Okay, and they are burning out at 33% a year. And because they're buying them, and there is an expensive purchase, right? Anytime you buy these things, so the company's buying them or amortizing them over 7 years, like you would any large purchase as a business. But at year 3, they're already at like 120 something % of the year 1 purchases, and they're not accelerating those write downs. Okay. And so to continue getting the purchases at this rate, already like people are talking about, oh, well, you're not gonna be able to scale, the investment that's going to take is going to be X, Y, and Z, and they're doing this off of the financials that are being reported by these companies and going and looking at it. Then you go actually look at what's actually happening. The problem's even worse, right? Because they're burning through these things way too fast. So Nvidia started investing in companies that are buying large numbers of Nvidia chips, and they are giving them grants. Those grants come with all sorts of strings attached to them. You have to use Nvidia chips, blah blah blah. But they're burning out these crazy fast, right? Because their general purpose, it's not what they were intended for. They're definitely not intended to run continuously at 80% cycle rates. So a couple of companies, Nvidia has bailed out 2 now that I know of, Groq and somebody else I can't remember the name of, where they just flat out purchased them when they were about to go under to continue getting them to buy their chips, right? Because now Nvidia owns it and they can play some tricks with their books. So to that end, I think it is important is going back to the original question about paying attention to stuff for your small business, because you don't want to end up on a service where they're going to either fold or get folded into somebody and that service isn't around anymore if you begin to rely on it.
That's a great point. That's a great point. Thank you for clarifying that and sharing that information.
Yeah.
And just to clarify even further, what you're saying is, and you said something that I think will resonate, because you have a lot of people who don't know a lot about AI and don't even realize that they use AI, every day, unbeknownst to them.
Sure.
But you said that the winners are people who are using AI for efficiency, right? And the losers are people who are trying to replace people or replace processes. And because AI is not there yet. And I think that's important to hear, important to say, because there are so many people that are just like, they don't even want to touch AI just because they think like, yeah, well, I don't want my team thinking that I'm trying to replace anybody by using this AI, not understanding that AI is a better partner than it is a boss, right? And so I just want to say I appreciate you for bringing that out.
Hey, what's up? I'm Clint. Thank you for hanging out with me on this one. If you're listening or watching this cut, the full episode is on techwingman.substack.com. Go subscribe. It's worth it. And if you're already a paid member, you're good. Keep watching. Either way, I'd love to hear your thoughts. I actually read that stuff. All right, back to the episode. Hey, one more thing. I know I don't always talk directly to who's watching and listening. I'm still figuring out this podcast thing. Bear with me as I build. I appreciate you being here, though, and staying with me this far. Thanks again. Now back to the episode.
Bringing that out.
Yeah, David, I see that. Go ahead, let it out. What you thinking?
I don't know. I think that there are definitely places where you don't want to use it. Like if you need privacy, like the financial sector, the companies that are aggressively moving into large language models and dumping all of their data over into whatever the Microsoft offering is that they've been scooping, Copilot, because they changed their data privacy stuff so much as soon as they started launching Copilot. It was ridiculous. You were absolutely giving all of that information over to Microsoft and ultimately OpenAI, and that ended up being a huge problem for some of these people at some point in time. How that manifests, I don't know, but I can tell you it's going to. But there's a lot of financial services companies that are like, yeah, no, we're just not going to use this right now. I think that's actually probably a pretty smart decision. So I think it depends on who you are and what you're doing, whether or not it's a good partner or not. But
yeah, I would also add to that the law and the industry, lawyers and not because I have a few friends who have had horror stories with they heard through the grapevine in the industry, people trying to use them at that point. What jumped out with what Hassan said and what you said, especially with buying. So there's this perception of how great AI is and what AI can do, especially from a small business standpoint. So I will just keep up with the news and I'll follow the news, but the news is also lying, which comes back to your point, David, that here you have this let's talk about Groq. Groq is this big thing and it's great, but then to hide what's going on in the books, they get bought by a bigger company. Now those are the two big ones we know about. What about all of the medium to small size AI startups? Like, yeah, I did an AI startup and I was successful. I got bought by these people when they were actually going down, because we already know the business model for at least prompting for tokens and whatnot is flawed already. So is this perceived of AI environment is doing good, but there's all these hiding the numbers through purchasing of companies and partnerships or whatnot. Like that's what it sounds like to me. What do you guys think about that?
Yeah. Let me hop in on that real quick. I think it's great that you brought that up, because you're talking about like small, maybe startup AI companies, but even OpenAI is they're questioning the books of OpenAI and the circular dealings that they're involved with. So it's funny because there's so many there's so many factors and different types of industry under this big tech umbrella that have all converged under this goal, this path of creating super intelligence, AGI, AI, that if this is a market bubble, it can get very, very interesting going forward, because everyone's really putting all their chips in one basket. And just from my understanding, like looking at things from more of a financial standpoint, it's extremely dangerous unless, we are fully committed as a country to follow through with this process and back them regardless, almost from the sense of government backing, which, some people would say we're already doing that. Right. But even from an official standpoint, where it's like, hey, regardless, this is what we need to do and this is what we need to focus on, because of things that have already come up in this conversation, where we have semiconductor manufacturing that's being bailed out by larger conglomerates and all this type of stuff and everything, and how everything's kind of housed under one sector. We are falling in line with the stuff that kind of happened in the past during the Roaring '20s, where we're falling into the whole monopoly
oligarchy,
sand trap. So that's just my contribution. You guys say whatever's on your mind.
There's a lot there.
There's a lot there. Like I start thinking about all of these factories, I guess you want to call them, that's going to be built in Texas to house AI data centers. Like when you were talking, that's what was going through my mind. I was like, yo, why are you building this stuff and we haven't even solidified things yet? But I'll let someone else answer, because over my head again.
Well, I'll tell you why they're building it here.
Oh, yeah.
That's power. Yeah. There's 3 power grids in the US. There's the west side, there's the east side, there's Texas. And Texas has more wind energy than any single nation in the world.
Really?
Yeah.
Didn't know that.
Yeah. Even though the grid, that was because they weren't ready for the winter. Like,
Yeah,
that's one of the things that, and it's Texas, so do you really want to? Do you really prepare for winter? Like, I get it. So,
at least the regulation is so loose that trying to get new transmission lines built isn't going to be as big of a headache as it is in the rest of the country if you can get the parts for it. Texas.
Yeah.
Interesting. So if that's the case about Texas, then what are they doing on the other coasts? I haven't heard news on the other coast. That's the question. Have you guys heard?
Arizona, I guess, is the only other place I've heard of, really.
Yes, which I've heard that as well.
There's been a lot of development in the Ohio area, South Carolina. Oddly, there's been a lot of data centers being built there. Yeah, I don't understand why. Greenville specifically.
Yeah.
I mean, you have a lot of the big car manufacturers down there. So I mean, there's.
But historically, hasn't there always been a lot of data centers in the North Carolina area?
No, it's all in Virginia.
Ah, okay.
Well, like Michigan area has a lot of car factories. I would assume that pulls a lot of power. So I assume then they'll build stuff in that area.
I don't know how big the factories are in Michigan for automotive anymore. Yeah,
outside of the Detroit. Yeah, I don't think it's really a lot there. Not like it used to be.
No. I mean,
yeah. I think you guys nailed it a second ago. Someone mentioned regulation, and I think that's really the key of where they're going to be able to build a lot of the data centers is just based on who can get it passed through, their local legislation to get them built. Because what's shocking is, and I'm somewhat kind of impressed, is the pushback from some communities is happening a lot faster than I would have assumed. I would have assumed that a lot of this would have gone, and it might have, there might have been some pushback maybe, 5-10 years down the road, but people have been pretty active. I'm sure a lot of that has to do with their electricity bills, but I'm just still kind of shocked at how it seems that people are paying more attention than they have traditionally.
And Texas water.
Go ahead. What were you saying?
I was just adding on to that, like not just the power, but water. Like Texas is
absolutely
very, very dry, and the aquifer is lowering. And that is something that when I first moved to Texas, I was slightly aware of. Like I came back here in high school, and but it's been such a constant thing where the aquifer. Like I've heard it every year. So now I think when it's coming to building these data centers, people are like, wait, we already don't have enough water.
Mm-hmm.
A lot of these places are liquid cooled. How are we going to support that? So I think the alarms were already up before they even started building.
Gotcha. I think it's also interesting too, because like a lot of manufacturing, like we're mainly concentrating on the data centers themselves, but like just in the Dallas, Abilene area, there's a lot of like manufacturers that are around too. So maybe it's the proximity to those manufacturers. Maybe that's also why Arizona might be a popular place. Or I think I want to throw in Nevada too, perhaps, but I'm not certain on that. And definitely, if water's an issue, Nevada's not a good place to build.
Yeah. Now, Arizona has a lot of solar. I think that they're concentrating these builds around power.
Yeah. So that got me thinking. Like to power these chips, these factories, it's all about power. And we got this Tesla battery. And then Kevin, you sent me that video the other day. I don't know much about physics, but I've been looking at some physics stuff. You sent me a video talking about free energy, how you can derive energy. My general question.
Tesla. Okay.
I mean, you got the Tesla battery.
Let's
go. I'm just saying, like, we have all these options saying, like, hey, you can get energy from solar, from wind, from free energy, from out of anywhere, but yet still we're focusing building in a particular area because we can't control that energy or somehow manufacture it. But in physics, there's a big question mark that maybe you can.
Free energy. Did Tesla build fusion reactors? I'm confused.
Here, let me clarify too. So there's yeah. So I think the thing that's really interesting is that and I don't want to say this lightly because lives are lost, but the gentleman who was recently assassinated, for lack of better words, the MIT professor
Oh
who
yeah.
who was shot. He was a physics professor who was doing some fantastic work, and I had no idea who he was, what he was doing, but I just did a little background work on it, and he was just doing work with plasma and fusion, like nuclear fusion, as opposed to fission. And then there's the conversation of, you know, what was he working on? What was the possibilities with that? And so that's where the concept of free, it's not necessarily free energy. It's just a cleaner energy source that would be derived from water, you know, when you're utilizing hydrogen as opposed to the traditional raw material sources that we traditionally use. So that's just where that conversation is. So I mean, if you guys are curious, I think his name is Nuno. It's Portuguese, so forgive me for butchering his name, but I think it's like Nuno Loureiro.
Oh, from the Brown, the same guy that did the Brown shooting, or he was murdered.
No, he was. So there was two. There was one at Brown, and then I think it was either that same guy or someone accomplished went to the other university and did something to him, and it was like his rival academically. So the thing is to just look into it, look at what he was trying to do. Like if you want to do some personal research, it's interesting the research that he was doing. I don't know if it's appropriate for this conversation because we're so early on as far as like nuclear fusion is concerned, but it's just an interesting topic.
Yeah. Interesting. What were you gonna say about Tesla, Tony?
Oh, Tesla. No, I was just talking about is the free energy concept. That's when I first heard from when I read about Nikola Tesla early on.
Gotcha.
That Tesla. Okay.
Not the current company named after him, but the actual physicist, Nikola Tesla. Yeah.
Gotcha.
That's when I first heard of that concept.
Yeah.
It's good stuff. There's a lot to follow. There's a lot to keep up. Going down the same concept of, you know, AI chips and power and what it needs to kind of go forward. I think one of the things, the general idea is that we want to keep up with the news and see what's all going on. And this is where I like to share. I think the last time we did this, share what websites you use to help to keep up. One of the websites that I use is Google Trends. I've been using that forever. Every once in a while, I'll still go back and use that. So if you guys have anything to share, any other websites to share, let me know. But for right now, I'm gonna share with you this one called AnswerThePublic. Have you guys heard of this before?
AnswerThePublic.
Oh, is that the
sounds vaguely familiar?
Isn't that the ex Microsoft executive, Bill Gates' partner?
I think it is. Yes.
Can't remember his name at the moment.
I'll have to go look it up to verify. What did you say?
Is it Steve Bollinger? You talking about the owner for the Clippers?
Oh, Ballmer?
No.
Ballmer. Yes.
Ballmer.
Oh, he did this?
Yeah, I'm pretty sure this is his.
So this is it's pretty cool. You put in a keyword and it goes and it searches everywhere, and even down to Google ad clicks, like how much per click this term is being used for, so people can use it in their marketing or whatever, right? And over on this side, it's showing you all the different keywords and areas and blah blah. But this is the part that I jumped out. It puts it in this nice little spiral, so you can kind of see where the term is coming up the most. And I found this to be interesting. To just putting in the term AI chip, and you know, a big segment of that is inherently related to AI models, which is true, right? But it's just how this can actually, you can use this to kind of get some more insights into specific topics.
Oh, it's interesting.
Oops,
yeah, it looks very similar though. By the way, his company is usafacts.org.
Yeah. Okay. And you know, you can see here, you can search by a country or whatnot. But what I just wanted to show you guys is, like, I put in AI chip, and I'm seeing stuff that piques my interest, like AI chip Halo, because I'm a gamer, right? So that stands out. But
Yeah,
do you guys
that's
need me to
interesting.
zoom in? Does anything here pop out to you?
The zoom, yeah, I think.
I just go down real slow here.
I think this is a really interesting site. Thanks for sharing it with me. So,
Yeah.
AI
great
chip
source of
human
information.
brain.
What did you say, Tony? I didn't hear.
No, AI chip human brain. That's
Oh, this one.
yeah. It's like, okay.
I wouldn't be surprised. What is that one Musk company that's trying to do that stuff?
Starlink.
Neuralink.
Neuralink.
Yeah, Neuralink.
Yeah. AI chip, do it yourself. What?
Yikes.
You guys want me to click on any of these, or do you have another interesting website to share? I kind of want to click on this human brain one.
The one
I gotta register.
Tie into what you guys were talking about earlier, or asking about China, Chinese chips. So there's some stuff about Huawei and
Hawaii.
some other stuff in there. There's something interesting. It's maybe going down a little bit of a tangent on China, but I mean, their population is aged out, but they also have the power infrastructure to run a lot of this stuff. They have the largest hydropower generation, like bar none, in the world, and they don't utilize hardly any of it. They just, because of the Roads and Belts initiative, they just had massive amounts of concrete production, so they just built dams and roads all over the place.
Mm.
This is what the other guy built.
The bomber.
This just a general thought?
This is Steve Ballmer. Yeah.
Oh, okay.
Yeah, I don't think it has anything pertaining to what we've been talking about, but it is a really good site when you're trying to find real information about topics.
About what you were saying about the it said resources and knowledge in China. Kevin, that stuff you sent me about school, was that China? I think it was.
Yeah, about the Gaokao test, the
Gaokao test.
Yeah, here, let me see if I can tie it into what we're talking about here. Well, let me start here. I think one thing.
How you spell it real quick? Let me look it up while you explain. I
think it's Gaokao. Gaokao.
Yeah, it is. I found it. Yeah, go ahead.
I think to bring it into context with this conversation is that something that's probably common sense, for everyone else in this conversation, but we really, as a nation, need to focus on education, which is obvious, but I'll say it anyway, mainly because the testing methods in China, as well as the fact that a lot of the data scientists are Chinese is a issue from a competition standpoint. And I mean, I don't know if necessarily in this conversation we'll be able to solve the education gap, but it is something for everyone to be aware of, that we gotta kind of step it up here, because competition's getting fierce, and we kind of are in a race for AI, whether we realize it or not.
Yeah,
that's all.
That's an interesting topic for sure. But I think, especially with China, you really have to look at their population issues. I mean, their median age in China is like 56 or 57 years old now.
Whoa.
Yeah,
I didn't realize that. Thanks for sharing.
Yeah, with their population death crossed like almost a decade ago. If you're not familiar with that, that's when your population is starting to age out. Like basically your ethnicity is dying. There's a geopolitical strategist who's done a lot of work on that. He's not everybody's cup of tea. His name's Peter Zine. You can go look him up and hear all about China and what's going on with China. But so China, while yes, they do have a very large population, they have done a really good job of going out and co-opting information out of other third world, or sorry, other nations, and getting people into top positions, et cetera, to either exfiltrate information or the people that took those jobs going back to China and starting new things. All that's happening to some degree, but it's not really that big of a deal because China's not. They don't have the population to continue it, right? Like they have that advantage. It's got a 10 to 20 year lifespan on it. If you want to talk about tech education or just education turnarounds in general, actually a really, really interesting story is Ireland. In the late 80s, they decided that they were just going to go all in. Ireland was not doing well. They were just going to go all in on their education system. And it paid off for the next 20, 30 years. That's why every single large organization, Google, Meta, you name it, you name a big company, they have a presence in Dublin because of the quality of workers that are there in the education system. Really, really fascinating story there. But I absolutely agree with you. Like our education system's a joke and it's getting worse by the day. So
yeah, I'm glad you mentioned that about Ireland because, like, as you were saying, they, most countries are headquartered there, and in addition, they've had a great turnaround in recent times, and it is a great model that I wish we could do it on a national level, but hopefully there will be some states that will start taking notes because I think just leading back into this conversation, I think the issue is like, all right, great. We all know that the jobs of the future are going to be changed as a result of AI, and it's like, how are we going to be prepared for this as a community, just from a community standpoint, and it's just something to think about. But yeah, thanks for mentioning Ireland because Ireland is awesome. It's I respect that country in so many ways.
yeah.
That's good. That's good stuff. We're getting close to the end here. Is there anything else you guys would like to share in closing? I found it very interesting because my brain hasn't solved this yet. But how an ex-Googler could just create a chip company and take over the world seems weird. I don't think that's just an education thing. That's probably I know a lot of people thing too.
Well,
he worked on the original tensor chips, right?
Okay.
So, yeah. He was there for
So
a decade. Yeah.
Isn't there some kind of intellectual property related with that?
Yes, there absolutely is.
But he's not in the U.S.
Yeah.
Okay. And then he gets to compete with the US. Like, I'm gonna come over here, use this, and then bounce, and then beat you. Okay.
Or think he can profit more in China, whatever.
Yeah. Hassan, you got any last questions as we wrap up? If he's not answering, I'm assuming he's pushing a plan. Keven, how about you?
I'm sorry.
Oh,
but no, I don't have any other. I really appreciate the watering down or dumbing down the conversation to help me understand a little bit better how things work as far as the AI space and the different technological terms and things of that sort. So I just appreciate you guys for that.
Yeah. We all need to practice that anyway, because we can go down the geeky aisle and lose everyone.
I mean, it's always good to learn more too, and I've already learned a couple things that I had no idea about today. So.
I learned a lot myself. Anything else you'd like to add, Tony?
Oh, no, I'm good. I'm good. This is always a good time, talking about just to talk about AI, just talk about the new stuff that's coming out, and how we as potential small business owners and small business owners can benefit and grow from that.
Absolutely. David?
Yeah. Well, I think first, Hassan, I think you downplay yourself a little bit. I mean, even techies speak over each other's heads sometimes. So that's why I brought this stuff down. But you bring some really interesting insights into this as well, which is always great to hear. But yeah, no, it was interesting conversation. I've learned a few things myself about a couple of things that I was unaware of. And it's always good to meet other small business owners, people starting stuff up. Tony, if you have a few more minutes, I'd love to hear more about what you're working on, how build your process.
Yeah.
Case.
Perfect. Kevin, anything else you want to add?
Nah, it was just a pleasure meeting you guys, letting me sit in, hear your thoughts, ideas, and I look forward to the next one. I'll try and adjust my schedule so I can participate a little bit more consistently. So
okay,
it was nice meeting you guys.
Perfect. Thank you, Kevin. This is just the way I started. This is just we just talk until we run into a block. And what I've noticed as this being the fourth one, we have a lot to talk about, so we don't run into any blocks. But what is great is the suggestion of the topic we got last time. So that's how we ended up here with our AI chips. So I'm posing the question to the room. Is there any topic you guys would like to talk about in the future? Just off the top of your head. If not, you can always message me later, but I'm probing the room right now just to see.